want to take a look at an application involving law of cosines. So I've selected an even numbered problem from the book. This is number 32 if you want to see it in the book, although I've got the relevant information summarized up here. I will confess I chose this problem because it involves bicycles, and bicycles make me happy. Okay, so we've got a cyclist here at point A, and the cyclist needs to get to point C. Now, if she's going to travel along paved roads, it's 18 miles to point B, and then 12 miles to point C, where these two roads meet at a 38-degree angle. Okay. The straight line path from A to C is obviously a shorter distance, but there's no paved road there. So we're told that the cyclist can travel 22 miles an hour on the paved roads, but only 6.8 miles per hour off-road. And the question is, which route is going to be fastest? To stick with the paved roads and go the further distance, or to take the shorter distance at the slower pace? To answer that question, we're going to need to know how far this actually is, and that's where the law of cosines comes in. So we're first of all going to find side B here, and then once we have that, we can calculate the times it would take along either route and see which one is shorter. Okay, so if we're solving for side B, B squared is A squared plus C squared minus 2AC cosine of B. By the way, I didn't tell you to pause the video to work this one out. You're certainly allowed to. I thought we'd work through this one together, but if you want to give it a shot on your own first, by all means, you always have my blessing to do that. Okay, so let's see. That's going to be B squared is 18 squared plus 12 squared minus 2 times 18 times 12 times cosine of 38 degrees. So let's work that out. That's going to be 18 squared plus 12 squared minus 2 times 18 times 12 times cosine of 38 degrees. I am still in degree mode. If you're not sure, make sure you check before you plug this in. Okay. All right. So I'm getting that B squared is 127.579 blah, 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 blah. So B would be the square root of that, which is 11.295 blah, 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 blah. Okay. Now, we weren't given a place to round to because we were asked actually just to figure out which route was going to be fastest. So I actually didn't want the length just so I'd know the length. I wanted the length so that I could figure out what the time would be. So I want to remember that distance is rate times time. Okay. So this distance, which is side B, this 11.295 blah, 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 is going to equal 6.8 times the time that it would take to travel off-road from A to C. So the time would be this 11.295 blah, 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 divided by 6.8. I've still got that on my screen, so I didn't need to round. I'm just going to go ahead and write here, type that I want to divide that by 6.8. And so I get 1.66 blah, blah, blah. Okay, so the time off-road is 1.66 blah, blah, blah. And that would be, of course, hours, because I've measured distances in miles and I've measured rates in miles per hour. Okay, excellent. So let's see the time that it would take along the road. Now along the road, our distance would be the 18 plus the 12. So that's 30 miles. Okay. So on road, distance is 30. That's going to equal 22 times that time. I'm just going to recycle the name T for that, but obviously it's a different T than we had before. So we're going to have 30 divided by 22. And I get that this time is about 1.363 blah, blah, blah. That's definitely smaller than 1.66 something. Okay, so the answer is it would be faster on the road. Not just in the sense that she's actually biking faster, but in the sense that the trip actually takes less time. All right, good stuff.